Yellowstone, scientists have found something they never expected: not lava, not earthquakes, but a hidden gas anomaly, an invisible signal rising from the Earth's depths. To most, it would be easy to overlook, but to volcanologists, this discovery is a red flag. The chemistry doesn't match ordinary volcanic emissions. It whispers of processes deeper, stranger, and potentially more dangerous than what we see on the surface. And here's the question we're left with: is this just a geological quirk, or the first clue to something far more serious? A warning sign from one of the most powerful supervolcanoes on the planet, unveiling Yellowstone's secret. The anomaly wasn't discovered overnight. It began with routine monitoring, geochemical surveys, and seismic sensors spread across Yellowstone's vast landscape. These instruments are designed to catch tiny changes, like a subtle shift in gas emissions or a faint tremor underfoot. What stood out this time was the chemistry. Levels of gases like carbon dioxide and helium weren't matching the usual volcanic profile. Even more striking, isotopic ratios, tiny atomic fingerprints, hinted at a source deeper in the Earth than typical geyser or fumarole emissions. At first, many scientists were skeptical. Could this just be instrument error, a temporary fluctuation? Some dismissed the signal as background noise in an already complex system. After all, Yellowstone is a living, breathing giant with countless hot springs, fumaroles, and geysers constantly releasing gases. Distinguishing a true anomaly from the everyday chaos is no easy task, but as the measurements piled up, the pattern refused to fade. The unusual gas signature kept showing up again and again, forcing researchers to reconsider. What they were seeing wasn't random. It was a consistent, measurable deviation, one that demanded explanation: the deep Earth connection. As scientists dug deeper into the mystery, they began tracing possible pathways for the gas. One hypothesis pointed to Yellowstone's immense magma chambers, the reservoirs of molten rock beneath the park. Another possibility reached even farther down, into the mantle plume itself, the hot upwelling of material that feeds Yellowstone's entire volcanic system. If true, this anomaly might be a rare glimpse into Earth's deep interior, something we almost never get to measure directly. But it wasn't just where the gas came from, it was what the gas was made of. The ratios of helium isotopes, along with other trace elements, didn't behave like the typical volcanic emissions measured at geysers and fumaroles. Instead, they hinted at a much older, deeper origin. Unlike the surface gases recycled from water and rock near the crust, these signatures looked primordial, possibly untouched since Earth's formation. That raised the stakes. This wasn't background noise, it was a fingerprint from the deep Earth. To put it in perspective, scientists compared Yellowstone's anomaly to other volcanic giants around the world. At Mount Etna in Italy, unusual carbon dioxide surges have been tied to magma movement. In Iceland, unique helium isotope ratios have revealed connections to mantle plumes beneath the mid-Atlantic ridge. Hawaii's Kilauea has shown similar deep source gases too, but Yellowstone's case appears different, more intense, more persistent, and linked to a supervolcano system that dwarfs them all. For researchers, this wasn't just another blip. It was a window into the engine room of one of Earth's most powerful geological features. And if it meant Yellowstone was breathing differently, the implications could stretch far beyond the park itself. Potential implications and risks. So, what does this invisible gas anomaly really mean? Could it be just another quirk of geology, or an early signal of something far more serious? For scientists, one chilling possibility is that this could represent a new kind of precursor to supervolcano unrest. Yellowstone has long been monitored through earthquakes, ground uplift, and thermal changes. But if deep Earth gases are suddenly shifting in composition or intensity, that could signal activity stirring far below the surface in ways we've never tracked before. Locally, even without a massive eruption, the risks are real. Changes in gas flow could disrupt Yellowstone's delicate ecosystem. Geysers and hot springs might alter their patterns. Wildlife that depends on thermal areas could be affected if toxic gases seep out in concentrated amounts. We've seen examples at other volcanic systems, like Italy's Campi Flegrei, where gas surges alone have damaged vegetation and reshaped local landscapes. And then there's the human side. If these gases, especially carbon dioxide or sulfur compounds, breach the surface in large amounts, they could accumulate in valleys or low-lying areas. In high enough concentrations, such emissions can displace oxygen, creating dangerous conditions for humans and animals. While there's no sign this is happening yet at Yellowstone, the possibility makes scientists pay attention. But perhaps the biggest implication is this: anomalies like these matter, even when they don't lead to immediate disaster. Every deviation from normal teaches us more about how supervolcanoes breathe, shift, and evolve. And in the world of planetary hazards, subtle changes can be just as important as dramatic explosions. regions. Because the sooner we recognize these patterns, the better chance we have of predicting what comes next. Cutting-edge research and monitoring. If this gas anomaly is real, then understanding it becomes a top priority. And for that, scientists are bringing in every tool at their disposal. First, satellites. Advanced orbiting platforms are now tuned to pick up even the faintest gas signatures above volcanic regions. They can detect subtle shifts in carbon dioxide, sulfur dioxide, and even rare isotopes, offering a bird's-eye view of Yellowstone's hidden breathing. On the ground, ultra-sensitive gas sensors have been deployed across the park. These instruments constantly sniff the air for changes in chemical composition, creating a live map of the invisible gases seeping from Earth's crust. Pair that with AI-powered seismic modeling, and suddenly researchers aren't just watching, they're predicting. Artificial intelligence can sift through mountains of seismic noise to catch patterns too small for the human eye, potentially spotting anomalies weeks or even months before they become obvious. And this isn't just one lab's project. The U.S. Geological Survey is at the center, working with university volcanologists from across the United States, and even collaborating with global partners who study other volatile regions like Iceland and Italy. It's a worldwide scientific network, all focused on one question: what is Yellowstone trying to tell us? Still, debate rages. Is this gas anomaly a legitimate warning signal, or just background noise being overinterpreted? Some volcanologists argue it could be a harmless byproduct of natural subsurface processes, while others warn that ignoring it would be reckless. So what comes next? Proposals are already on the table. Some researchers want to drill carefully into Yellowstone's crust, not to release pressure, but to sample gases directly at their source. Others push for expanded, long-term monitoring networks and computer simulations that can model how the supervolcano might behave if such anomalies persist or intensify. The bottom line? Yellowstone is one of the most closely watched volcanoes on Earth, but this discovery proves we're still only scratching the surface. Safeguarding our planet. Yellowstone's gas anomaly isn't just a local mystery, it's a global warning. Supervolcanoes are scattered across the Earth, from Toba in Indonesia to Campi Flegrei near Naples to Taupo in New Zealand. Each has the power to alter climates, disrupt food chains, and threaten civilizations. What we uncover at Yellowstone could become a blueprint for how to monitor all of them. But science alone isn't enough. The way this information is shared matters just as much as the data itself. If scientists cry danger too soon, it risks panic. If they wait too long, it risks disaster. That's why transparent, clear communication with the public is critical, so that people are aware, prepared, but not paralyzed by fear. And beyond communication, there's action. Every gas sensor, every seismic probe, every satellite pass contributes to one ultimate goal: readiness. The truth is, humanity can't stop a supervolcano from erupting, but we can buy time. Time to evacuate, time to protect crops, time to adjust our infrastructure. Even a few weeks of early warning could save millions of lives. So while Yellowstone's gas anomaly may seem like a small puzzle piece today, it could be the cornerstone of tomorrow's planetary defense. Watching, learning, and preparing. Because when Earth speaks from deep below, we can't afford to miss the message. The bigger picture. Yellowstone's gas anomaly isn't just about one park in Wyoming. It's a window into Earth itself. Deep beneath our feet, hidden processes are unfolding on timescales so vast, they make human history look like a blink. For scientists, Yellowstone is more than a supervolcano. It's a laboratory, a natural observatory where we can glimpse the machinery of the planet. But as we study, we're reminded of something humbling. Humanity's place in this story is fragile. Civilizations rise and fall in the span of thousands of years, yet volcanoes measure their cycles in tens of thousands, even millions. To them, we are temporary guests living on borrowed time. This is the balance we face. On one hand, the thrill of discovery, learning more about how Earth works than ever before. On the other, the shadow of risk, knowing that these same forces could reshape our future in an instant. Yellowstone's anomaly forces us to live at that intersection, between wonder and worry, between scientific insight and existential threat. The question is not just what we'll learn, but how we'll use that knowledge to protect, to prepare, and to respect the immense power of the world we call home. Maybe this gas is nothing more than a harmless curiosity, a geological quirk buried deep in Yellowstone's restless heart. But maybe it's something more. A whisper from Earth's depths, a signal too faint for most to notice, but too strange for scientists to ignore. We like to think of Yellowstone as a park, a place of geysers, hot springs, and breathtaking scenery. But beneath the surface lies a force powerful enough to reshape continents, climates, and civilizations. This anomaly reminds us that the Earth is alive, and sometimes it speaks. So the haunting question remains: if Yellowstone is speaking to us, are we really listening? This is the frontier where science meets survival, survival, where mysteries beneath our feet carry the weight of our future. And if you want to stay ahead of the discoveries that shape both our planet and our place in the cosmos, join us here on Space Prime, because the unseen threats are often the ones that matter most.